the end of the fourth week in February 2025. Here's the science and space headlines we followed through the week. New Marsquake data could help solve one of the solar system's biggest mysteries. Saturn's rings might be deceptively old based on what we thought we knew. And the slowest rotating cosmic lighthouse yet discovered.
21 years online. From Star Trek to science and space. And we're not stopping. This is Talkin' Science.
New analysis of Marsquakes, which are similar to earthquakes, could offer clues into how Mars has evolved over billions of years, according to new research from the Australian National University and the Chinese Academy of Sciences. The researchers say differences between the two hemispheres of Mars were likely shaped by convection, the transfer of heat from one place to another, in the Martian mantle over hundreds of millions to billions of years ago. The mantle is the inner layer of Mars, sandwiched between the crust and the core. According to geophysicist and study co-author ANU Professor Hedove Telčić, the difference in the red planet's hemispheres is one of the biggest mysteries in the solar system, and there are two competing theories to explain it.
One of them is the so-called exogenic hypothesis, which basically means that either a giant impact or a series of smaller impacts created that dichotomy. And the other one is endogenic hypothesis, which states that probably the internal dynamics of Mars, either in the form of mantle convection or similar, would cause the differences in Mars that we observe today.
According to the researchers, the InSight lander could become a prototype for future planetary missions. That lander collected data about Marsquakes, Martian weather, and the planet's interior from 2018 to 2022. My deep dive with Professor Telčić is available now for the world. It was available first for members, so become one today. International researchers have found a giant planet transiting a very young star in research that indicates this could be the youngest transiting planet found to date. Scientists have previously discovered more than a dozen transiting planets, which are planets that pass between a star and an observer, such as us here on Earth, around stars that are 10 to 40 million years old. However, there have been no detections of younger transiting planets, possibly because they haven't fully formed yet, or because the planets are blocked by the dust and gas from newly formed stars. Madison Barber and colleagues analysed data on the young, at 3 million years old, star with unique features that have allowed them to view the transiting planet via NASA's Transiting Exoplanet Survey Satellite, or TESS. The planet seems to be a precursor for the super-Earth and sub-Neptune planets often found orbiting sun-like stars. The researchers hope it could be useful for studying the early stages of planetary formation. Now, given the young age of this star and planet, the rare disk misalignment, and the relatively close proximity to Earth, the authors suggest that this system could be a useful target for studying the early stages of planetary formation. Well, even though Saturn's rings appear clean and young, they may be as old as the planet itself, according to international researchers. It was previously thought that impacts with small rocky debris travelling through space, called micrometeoroids, would dirty and darken the rings over time. But in 2004, the Cassini spacecraft revealed the rings to be clean and bright, suggesting they're not very old. The new research by Ryuki Hayodo and colleagues simulated collisions between micrometeoroids and icy ring particles using computer models, finding that high-speed impacts can lead to vaporization of the micrometeoroids, with that vapor then expanding, cooling, and condensing within Saturn's magnetic field to form charged nanoparticles and ions. The simulations revealed that these charged particles then either collide with Saturn, are dragged into its atmosphere, or escape the gravitational pull of the planet entirely. As a result, the authors suggest that very little of this material is deposited onto the rings, keeping them in relatively clean condition. They suggest that very low levels of pollution may mean that Saturn's rings are actually billions of years old and are simply maintaining a more youthful appearance. Although further research is required, the authors suggest that this process could potentially also be occurring in the rings of Uranus and Neptune, as well as on icy moons around giant planets. An international study led by Australian astronomers has created the most detailed maps of gravitational waves across the universe to date in 3 new research papers. The studies also produced the largest ever galactic scale gravitational wave detector and found further evidence of a background of these invisible yet incredibly fast ripples in space that can help unlock some major mysteries of the universe. This international effort, conducted with the Meerkat Radio Telescope in South Africa and led by astronomers at Swinburne and Monash universities, includes 3 studies published in monthly notices of the Royal Astronomical Society. Together, these works offer new insights into the universe's most massive black holes, how they shape the universe, and the cosmic architecture they left behind. Using the pulsar timing array, the researchers constructed a highly detailed gravitational wave map, improving upon existing methods. This map revealed an intriguing anomaly, an unexpected hotspot in the signal that suggests a possible directional bias. The presence of a hotspot could suggest a distinct gravitational wave source, such as a pair of black holes billions of times the mass of our Sun, lead author of one of the studies and Ozgrav researcher Rowena Nathan said. With continued work using the Meerkat array and plans to better understand the pulsar network and gravitational wave signal, researchers aim to refine the map of the gravitational wave background and verify the underlying cosmic structure. Lead author for the other 2 papers and a researcher at Ozgrav as well and Swinburne University, Dr. Matt Mills, says the research opens new pathways for understanding the universe that we live in. Distant neutron stars typically spin with a full 360 degrees within seconds. However, a new type of radio transient object, so called as they are detected in radio waves, has emerged that rotate much more slowly. In the time it takes this cosmic lighthouse to rotate, you could watch Interstellar twice before it completes a full spin. Research led by PhD student Ewing Joshua Lee and supervisor Dr. Manisha Caleb at the University of Sydney has uncovered the slowest cosmic lighthouse yet, a long-period radio transient, likely a neutron star, spinning once every 6.5 hours. This discovery, found using CSIRO's ASCAP radio telescopes and published in Nature Astronomy, not only pushes the boundary of what we thought possible for such objects, which typically rotate very quickly, but also reveals a rare phenomenon, the ability to see radio pulses from both of the star's magnetic poles. The abstract of the paper notes that ASCAP J183950.5-075635.0 boasts the longest known period of this class at 6.5 hours. It exhibits emission characteristics of an ordered dipolar magnetic field with pulsar-like bright main pulses and weaker interpulses offset by about half a period that are indicative of an oblique or orthogonal rotator. This phenomenon, observed in a long-period radio transient, confirms that the radio emissions originate from both magnetic poles, and that the observed period corresponds to the rotation period. The spectroscopic and polarimetric properties of the object are consistent with a neutron star origin, and this object is a crucial piece of evidence in our understanding of long-period radio sources and their links to neutron stars. Well, that's a wrap on the 4th week in February and the 2nd month of 2025. I'll be back for more Talkin' Science Daily Bites in YouTube Shorts on TikTok, Facebook, Instagram and LinkedIn. Find us, like, follow and subscribe. Become a member too to get early access to our Monday deep dives. It's all part of our 2025 commitment to bringing you science and space news and views with an Aussie flair.